So, page 352, number 1. The graphing starts on number 5. So, it just says evaluate. We're talking about exponential functions. So, on these functions, and we're doing some more of this tomorrow, the exponent has the variable. So, on number 1, it's really short. It just says evaluate when x is 5. So, what is 1/2 to the 5th?
1/3. 1/10.
That's right. How'd you know that? Did you plug it in the calculator? Okay. How does this actually work though without a calculator?
That's just like 1/2 plus 1.
Not plus.
Times, sorry.
Yeah. And when you do like 1 times 1 times 1, what's that? 1. And when you do 2 times 2 times 2, what's 2 to the 5th?
Or whatever Skylar said.
32.
32.
So it's just 1/32. It's not that complicated. So
Did you just talk into like an accent?
the more
He yawned.
times that you multiply a fraction by itself, it gets smaller and smaller. Half of a half is 1/4. Half of 1/4 is 1/8. So the numbers get smaller and smaller. Number 3, y equals 3 times 4 to the x. We're supposed to use x equals 3. What do we do first? Do we do 3 times 4 or 4 to the 3rd first?
4 to the 3rd.
Does anybody know what 4 to the 3rd is? 4
4
times 4 is
64.
64. 3 times 64 is...
192.
Oh, you're a genius.
Oh my goodness, Skylar, you're so brilliant.
Lying's not okay, Mr. Gruden.
What?
Lying's not okay.
You lie every day. What are you talking about?
Yeah,
You're lying.
That's a lie. Yeah, but
Yeah, that's how.
he's a role model.
I'm a role model.
You lie every day when you say that you're vegetarian.
No, because she eats pork, you know, like things of that.
Wait,
Last night.
you eat pork, but you're vegetarian?
I don't eat pork. I eat no meat. That is the definition.
You know they lie.
Y'all are dumb.
God, bro, porks are an atom, dude. What are you talking about?
Every business is corrupt. You don't eat it, but they actually do.
And fish.
I don't make it.
She doesn't eat any.
Oh,
So you're a pescatarian. But she eats chicken.
Fish is like the nastiest thing in the
It's
world.
really, it's honestly.
Okay.
Like, what you do.
So, number 5, we're supposed to graph these. So, how do you think I'm going to figure out what the graph looks like for this?
Well, you would, originally, I don't know what you do. Obviously,
If I don't know what the graph looks like, how do I figure it out?
Plug in numbers.
Plug in numbers
That was a good guess.
for x. Okay, and see what comes out for y, and those are the points on the graph. So, here's the numbers I want you guys to plug in on all these.
Ooga booga.
-2 to 2. It's like right in the middle from left to right.
the usual.
Okay, now let's see if you guys remember. I think this was last week. 3 to the -2. So I'm putting -2 right there. Is what?
Negative 9.
1/9.
1/9. It's 3 squared on the bottom. 3 times 3, but flip, so it's 1/9. Okay, what is 3 to the -1?
Negative, or
No.
we never use decimal.
Just flips it. 1/3, no decimal, no. What's 3 to the 0? Put 0 right there.
1.
1. If you're not sure, you check with the calculator. What's 3 to the 1?
3.
What's 3 squared?
9.
Okay, so -219
I reckon it's two.
is just barely off the x-axis. -1 1/3 is a little bit higher. 0 1. So 3 4 5 6 7 8 9.
The Fortnite battle bus sound.
I mean,
I don't know.
You hear that too, right? Like, I'm not going crazy.
no, you ain't wrong.
Yeah, you are.
You wouldn't understand.
Well,
Okay,
Yes.
do you guys see how this line is going up faster and faster and faster?
It's like,
Okay, why is it doing that? Because what we're doing is multiplying by threes. So 3 times 3 is 9, times another 3 is 27. So it goes from 3 to 9 to 27. So it goes up faster and faster every time you multiply by another 3.
Bro, this looks like the stomach.
This is called exponential growth. Exponent has the variable and it grows faster and faster and faster, so it's exponential growth. But what's happening over here on the left side? It's getting smaller and smaller. Will it ever get below 0 or will it ever get to 0?
no.
Well, if I plug in like 3 to the negative a million or something, negative 100 we'll say, that's like 1 over 3 to the 100th. And 3 to the 100th is like a bajillion. So what's 1 over a really big number? It's still bigger than 0, but it's not going to equal 0 ever. So it always gets closer and closer to 0 without ever getting there.
That's disgusting. It's so unsatisfying.
That's not very nice.
Terrible ending.
Alright, are you guys done with that one?
Yes.
Number 7.
Yes. Number
7 is 2/3 to the x.
It's not funny.
So we're going to use the same numbers as last time. Alright, let's start on the bottom though. Maybe you guys can figure this out. What is 2/3 squared going to be?
4, 6. This is
4 ninths.
Yeah, 3 times 3 is 9. So yeah,
Oh,
4
my bad.
4 ninths. What's 2/3 to the first power?
2/3.
2/3. What's 2/3 to the 0 power?
1.
2/3 to the negative 1.
3 over 2.
Negative 2. Oh.
3 twos.
3 over 2. 3 halves. 2/3 to the negative 2.
9 fourths.
9/4. So it's basically this, just upside down when you do the negatives. Exponents. Negative exponent just flips it. Okay, now we actually have to graph these. So what's 9/4 as a decimal? 9 divided by 4 is 2 with the remainder of.
20.
So it's like 2 and 1/4 or 2.25. What's 3 halves? 3 divided by 2? 1. 1.5, right? 1 with the remainder of 1. Anyway, yeah, we're decimal. So that's just to help us graph it. So negative 2, 2 and 1/4. Right about there.
So they always look like the top one.
Well, let's find out. Negative 1, 1.5. 0, 1. 1 2/3. Where's 4 ninths at? Well, 4 is a little bit less than half of 9, right? So it's a little bit less than half.
Wait, it says. No.
Okay, you guys see what's happening?
Bro, who is clicking?
I don't know.
Okay. How is this one?
From.
Shh. How is this one different from number 5?
Because it's not accelerated as much.
Okay. Well, that's true. It's going
It's going the opposite.
It's going the opposite direction. It's falling instead. So this would be exponential decay. It's dropping off. What's the difference? Listen up. What's the difference between why is this one going down and number 5 is going up?
Well, because it's decreasing.
Why is it decreasing?
Fraction.
Yeah, because it's fraction. When you multiply by a number less than 1, what happens to the value? It gets smaller and smaller. So number 5 was multiplying by 3 over and over, so it kept getting bigger faster. All right. Number 9. Y equals 2 times 3 to x.
You really got me there.
Okay. So number 9 is a good example of, you might want to find out what your points are before you graph, because what do you think? Number 9 looks like number 5, except for there's a times 2 right there. What do you think the times 2 is going to do to the graph?
Double it.
It's going to make everything twice as tall.
Why is the X down there? Shouldn't it be an X bar? What are you talking about?
Oh yeah, sorry. Alright. You can kind of use number 5 and cheat on this one. Do you know how?
Yes, I love that.
Who loves cheating? It's not the same. It's close to the same.
Just make it double.
Instead of dividing
Double
those
it.
times?
Well,
Double it.
after you plug it in, it's times 2. So we can kind of take our answers from number 5 and do times 2.
So 1 over 9.
Like, for example, it was 1 over 9, but now times 2, you guys know what that is?
No.
2 9.
2/18.
2 nines. You do that without a calculator?
No.
I was almost impressed, but I wouldn't have betted on it. You use the calculator every time.
But you don't see me use it.
It's true. All right. So 3 to the negative 1 is 1/3 times 2
2 3.
is 2/3.
I did that without calculator.
I did.
That was really easy.
Oh, it's not any harder than that one. Anyway, so 3 to the 0 is 1 times 2 is 2.
I did that
3
without a calculator.
3 to the 1 is 3 times 2.
6 and then 8.
3 to the 2 is 9 times 2 is 18. Okay, now if it's going up to 18,
Double it. Make
Let's-
it 2.
let's count by 2s.
But then there's a fraction, so it's gonna be like half of that size.
Where you count by.
That's right. It does make it really complicated. So if you want to keep it simple, you could count by 1s.
By ones. I'm just gonna make myself a
But my graph doesn't go up to 18 and still be on the same page. So I'm gonna count by 2s. If you're counting by something other than 1, you need to say so. Like put 2s there or something.
You can count by whatever. Dude.
Don't expect me just to assume I know you're counting by 2s.
Mr. Jordan just assumed that I'm counting by 2s.
Okay, so it is trickier to count by 2s because everything's going to be half as far as normal.
We got
So negative 2, for example, would actually be right here instead of right here. So, and 2/9 would look more like 1/9.
yeah.
So it looks like that.
My brain. It's just not.
Okay, if you don't like this, you can go all the way up to 18. Okay.
I know.
Negative 1 2/3. Negative 1 would be halfway, right there. 2/3 would only be 1/3 tall.
I'm gonna put a random dot and hope I'm
I
right.
made it.
Yeah.
Hallelujah.
Because we're counting by 2s, 2/3 would only be 1/3 of the way up. 2/3 of 1 is like right here, right? So 2/3 is not very high. Okay, where's 0 2 gonna be at?
Right on the toe.
Right, well, I put a 2 there, so that helps.
Ooh,
Where's 1 6?
on the 1 6.
So 1 is right here.
Oh really?
So 6 is 2 4 6.
So 1 6.
Okay, and then the reason we were counting by 2s, 2/18. 2, 2, 4, 6, 8, 10, 12, 14, 16, 18. Just goes up 9.
2, 4, 6, 8, 10, 12, 13, no.
14.
2, 4, 6, 8, 10, 12,
I still don't have
14, 16.
You guys have problems.
Okay.
Gorgeous.
So when you're counting by twos, it's kind of like you zoomed out. You're twice as far away. So what happens is it's going up very, very quickly.
It's always like zooming in and out like this.
Really trying there. He's evolved.
Okay, number 11, last one.
Yeah, that's how you please.
This is how you please Easton. You get rid of the yourself.
What do you mean by that?
Nah, Easton. Nah, bro. Nah. That's not what
You said it, not me.
Nah, you took it that way.
I was just asking.
Y'all are weird.
Oh,
You guys are really weird.
I just realized, that they made a table for us. I didn't even look at that. That's okay, we'll
Do
see.
we stick with our own table?
Well, their table is almost identical to ours,
They added an extra.
on number 7 and 11 they added, so yeah, some extra.
And 11 and 12
Can we not do that?
and 8.
Yeah, it's fine,
Yay.
just do 5.
Thank you.
Alright, on number 11, there's kind of a way,
Sorry about that.
Wait, guys.
there's kind of a way, does number 11 look familiar?
Yep.
Nope.
Yes.
What's it look like?
Kind of looks like
I
7.
don't know.
It's 7 except for what?
Times 3.
It's times 3. So we could take our answers from
We can cheat again.
7 and do times 3.
That's what I'm about.
So our first answer on number 7 was 9 over 4. Well, how do you do that times 3?
You get 27 over 4.
Yeah, it's just 9 times 3. 27 over 4. Our second answer on 7 was 3 over 2.
So 9 over 2.
So 9 over 2.
I am so genius.
Yeah.
That's funny.
Okay, when we plugged in 0 and 7, we got 1. So 1 times 3 is 3. When we plugged in 1, we got 2/3. What's 2/3 times 3?
2.
Goes like this. Goes like this, right? So it's just a 2.
What about it?
And then 2/3 squared was 4/9.
Let me guess. It's 1.
4/9 times 3,
4/3.
4/3.
I'm at 4/3.
You wrote that.
Okay,
It was really weird.
because we are graphing these,
We're so weird.
let's change our improper fractions into mixed numbers or decimals. How many times does 4 go into 27?
6.75 times.
6 with the remainder of
75.
3. Okay, 9 divided by 2,
Those.
4.
Not even close.
4 with the remainder of what? 1.
I don't know why I said.
The divisor just stays the same. Your remainder goes on top, the divisor. You guys remember how to divide?
Dividend.
9 divided by 2 is 4. 4 times 2 is 8. Remainder of 1.
He needs a woman to do his work.
Pick it up.
He needs your mom.
Okay, so 4/3. What's 4 divided by 3?
1 and 1 is
1
1
and
and
a third.
remainder of
1
1.
and a third.
Okay, so is this one going up really tall?
Yep.
No. So it only goes up to 6 3/4, so we can count by ones here. Okay, -2, 6 3/4. Okay, -1, 4 1/2. 0, 3,
Really?
1, 2, 2, 1 1/3.
She went to